Alright, in the last lecture we have learned how can we search for a node in double linked list. Now in this lecture we will look at how can we delete a node from a double linked list. Now the process of deleting a node from double linked list is similar to single linked list, but here we have small differences. So we are going to talk about these differences in this lecture over here. As in a single linked list, here also we have three cases of deleting a node from double linked list, which are deleting a node from the beginning of double linked list, deleting a node from any given location in the double linked list, and deleting a node from the end of the double linked list. So first we are going to look at how can we delete a node from the beginning of double linked list. So how can we delete first node from double linked list? Now here also we have two cases. Now the first case is if we have only one element in our double linked list. So how can we delete it? Now here it's obvious that we have only one node in our double linked list, so we have head which is referenced to this node and tail also referenced to this node, because here we have only one node. Now to delete this node from the memory, all we have to do, we have to set head to null and tail to null. Now if we set head to null, the link between head and this node 1 over here gets destroyed. Then if we set tail to null, the link between tail and this node 1 gets destroyed. Now with this node is not referenced by any head or tail or node over here. So this means that garbage collector can delete this node from the memory, because we know that if a node is not referenced by any node or head or tail, then in this case garbage collector deletes this one from the memory. So with this we have successfully deleted a node from the beginning of double linked list if we have only one node in our double linked list. Now the second case is we have more than one node in our double linked list. Now in this case we want to delete first node from this double linked list, so our first node is node 1. So the question is how can we delete this? Now here again, the first thing that we are going to do, we have to break a link between head and this node over here, and then we have to break a link, backward link that comes from the node 2 over here, because as we said before, if a node is not referenced by any node, then in this case garbage collector can delete this node from the memory. Otherwise it cannot be deleted. So that's why we are going to update head reference to point to node 2 over here, because in this case when we are deleting node 1 from here, the node 2 becomes the first node of this double linked list. So this means that head has to reference to this node over here. So this node's physical location is 111. So this means that I'm going to update head to 111. Now if I update head to 111, it creates a link between head and node 2, and a link between head and node 1 gets destroyed. Now the next step that we have to do, we know that in case of double linked list, first node's previous reference is always null. So in this case, we have to update second node's previous reference to null, because this is going to be the first node in our double linked list. So I am going to set the previous reference of node 2 to null. Now if I set previous reference of node 2 to null, the link between node 2 and node 1 gets destroyed. Now here we see that this node 1 is not referenced by any node over here, so this means that the garbage collector can come and delete this node from the memory. Now with this, we have successfully deleted an element from the beginning of the double linked list in which we have more than one node, and here the second node becomes the first node after deletion of node 1 from here. Now the next case is we are deleting a node from any given location. So let's say we want to delete node 3 from here. Now here, the first step that we are going to do, we have to loop through this double linked list until we reach the node which is located before the node that we want to delete. Now in this case, the node that is located before node 3 is node 2, so we have to loop through this double linked list until we reach node 2. Now when we reach node 2, we are going to stop over here. So the next thing that we are going to do, we have to delete the links that comes to node 3 over here. Now you see that a link from node 2 comes to node 3 and a link from node 4 comes to node 3. So we have to delete these links over here. Now after deletion of node 3, the third node becomes node 4. That's why we have to create a link between node 2 and node 4. So to do so, we know that node 4's physical location is 333. So this means that if I update node 2's next reference to 333, it's going to create a link between node 2 and node 4, and a link between node 2 and node 3 gets destroyed. Now the next thing is we have to create backward link from node 4 to node 2. So we have to update the previous reference of node 4 to the physical location of node 2. Now the physical location of node 2 is 111, so we are going to update the previous reference of node 4 to 111, and with this we are creating backward link between node 4 and node 2, and backward link from node 4 to node 3 gets destroyed. Now with this you see that node 3 is not referenced by any node over here, so this means that garbage collector can come and delete this one from the memory. Now after deleting it, the next node that comes after the node 2 becomes node 4 over here, and we have forward link and backward link between them. Now with this we have successfully deleted a node from any given location in double linked list. Now the next condition is we want to delete a node from the end of double linked list. Now here also we have two cases. So the first case is in which we have only one element, so this is the same as the one that we deleted the node from the beginning of double linked list, because here the first node is also the last node, so all we have to do, we have to delete link between head and this node and tail and this node. So to delete a link between head to node 1, we have to update the reference of head to null. So by doing so, a link between head and node 1 gets destroyed. Then similarly, we are going to update the tail to null, and by doing so, a link between tail and node 1 gets destroyed. Now here you see that node 1 is not referenced by anyone, so this means that it's going to be deleted from the memory. So garbage collector deletes this one from the memory. Now the next case is if we have more than one element in our double linked list and we want to delete the last node from double linked list. Now here the logic is different, because all we have to do, we have to create a link between tail to the node that comes before the last node. So then we have to set these nodes, node 3's next reference to null, because this is going to be last node in our double linked list. So this means that the next reference of last node in double linked list has to be null. Now here the first thing that I'm going to do, I'm going to update tail to the physical location of the node that comes before the last node. So node 3 comes before the last node, and physical location of node 3 is 222. So I'm going to update tail to 222, and this creates a link between tail and node 3 over here. And a link between tail and node 4 gets destroyed over here. Now the next case is we have to update the next reference of node 3 to null, because this is going to be the last node in our double linked list. So this means that the last node in double linked list has to point null. So if I update to null, the link between node 3 and node 4 gets destroyed. Now you see that node 4 is not referenced by any node, any tail or any head. So this means that garbage collector can come and delete this node from the memory. Now with this, we have successfully deleted last node from the double linked list in which we have more than one node. Now with this, we have come to the end of this lecture. So in this lecture, we have explained 3 different cases of deletion of a node from a double linked list. Now the first case was we are deleting a node from the beginning of double linked list. Now the second case is we are deleting a node from the any given location in double linked list, and the third case is we are deleting the last node. Now here I have explained the logic behind this solution, so hopefully everything is clear about this. Now in the next lecture, we are going to combine all these 3 cases in one algorithm to make our life easier to create deletion method in practice. Now see you in the next lecture.